A rectangular beam of 600 by 300 mm was simply supported over a clear span of 6 meters. If superimposed load is 30 kN per meter and support width is 50 centimeters each, find out the factored maximum bending moment. Use M15 mix and tar steel. The load factor is given as 1.5. So the effective span is equal to 6 plus the 50 centimeter support. So 0.25 on this side, 0.25 on this side. So it is going to be 6.5 meters. Dead load from the dimensions that were given, 0.3 into 0.6 into 24 into weight of concrete, we will take it as 24, 4.32 kilonewton per meter. Superimposed load, is equal to 30 kilonewton per meter. So factored load is going to be 34.32 into 1.5, that is 51.48 kilonewton per meter. So what we have to calculate is factored maximum bending moment. Factored maximum bending moment is equal to WU L square by 8. WU is the factored load, that is 51.48 into L is span, effective span, 6.5 square divided by 8. That will come to 272 kilonewton meter. 272 kilonewton meter, option D is correct. Is find out the lever arm for this section shown in the figure. Figure is given the width of 250 and depth of 400, and the 3 rods of 16 mm diameter were used, and the FCK of concrete is 25 Newton per millimeter square, and Fy is given as 415 Newton per millimeter square, right? So we have to calculate the lever arm for this section. So lever arm is equal to D minus 0.42x. D is effective depth. Force in compression. We know that 0.36 FCK B into X, that is 0.36, B is 25, B is 250 into X, that is 2250x newtons. Tension, force in tension is equal to 0.87 FyAST, that is 0.87 Fy, number of bars 3 into pi by 4 D square. D square is 16 square, that is equal to 217700 newtons. So equal to, for a balanced section, force in compression is equal to force in tension. So 2250x is equal to 217700. X is equal to 96.8 millimeters. XM is equal to 0.48 D for this steel, that is equal to 0.48 D is 360, that is equal to 172.8 millimeters. Which is greater than actual X. So lever arm Z is equal to D 360 minus 0.42, X is 96.8. That implies we will get 319.35 millimeters. If it is less than X, then we have to take this value instead of this value. So this is 319, option B is correct. A laboratory experiment. A crude oil is flowing through a pipe of 30 mm diameter. Diameter of the pipe is given with a velocity of 2 meters per second. During this experiment, a pressure difference of 150 Newton per millimeter square was recorded from two pressure gauges 7 meters apart. The distance between the two gauges is 7 meters is given. Find the viscosity of flowing fluid. We have to calculate the viscosity. So the diameter, we will convert the entire thing into a single uniform units. That is, into centimeters we will convert, and D is given as 30 millimeters. D is equal to 3 centimeters. We can take V is equal to 2 meters per second, that is 200 centimeters per second. P1 minus P2, pressure difference is given as 150 Newton per millimeter square. Newton per millimeter square, that is equal to 1.5 Newton per centimeter square. Okay, the distance between the two gauges is given as 7 meters, that is equal to 700 centimeters. So we know the relationship between pressure difference and the coefficient of viscosity of flowing fluid. P1 minus P2 divided by is equal to 32 mu VL by rho D square. P1 minus P2 is 1.5, 32 mu is, we have to calculate, we know 200, L is 700 divided by 1 into 3 square. Mu is equal to 3 into 10 to the power minus 6 Newton second per centimeter square. That is option A is correct. What is the intensity level if the sound intensity 45 dB increases by a factor of 500? So increase in intensity. After increases by a factor of 500 is equal to 10 log base 10 into factor, that is 500. We will get the value is 26.9, approximately 27. So increase in intensity level. Actual intensity plus increase in intensity is equal to 72 decibels. 72 decibels, option B is correct. As the annual moisture content, that is AMC of soil, is 13 centimeter per meter depth of soil. If a crop with root zone of 0.8 meters and consumptive use of 5 millimeters per day is to be grown, the frequency of irrigation restricted the moisture content. By restricting moisture content, the frequency of irrigation, restricting moisture content depletion to 50% of annual moisture content, AMC is. We have to find out the frequency of irrigation. So for 1 meter depth of soil, moisture content required is 13 centimeters, and what is the value for 0.8 meters? That is going to be 10.4 centimeters. So you see the annual moisture content required, or that has to be supplied, the frequency is going to be 10.4 divided by 0.5, that is equal to 20.8, approximately 20 days. Let me take. So for 20 days, here the condition is given as depletion of 50% of moisture content, restricting the moisture content to 50%. So 50% of AMC is going to be 10 days. So option D is correct.